Let's go over the direct evidence for neuromechanical matching. These studies were done to directly test the hypothesis and find a link between internal moment arm length and activation, and did so very carefully to avoid things like crosstalk, and thus hold greater weight to other indirect studies that were not done to address neuromechanical matching, and thus were at a greater risk for issues like crosstalk. Now I'm going to start by going over the studies done on respiratory muscles. Now people are like, oh, that doesn't apply to the muscles I train at the gym, but like, why not? There's muscles in the same way that my bicep is a muscle. Like when you breathe, you have to have muscles elevate your ribs and stuff. Like your brain wants to minimize wasting energy as much as possible in the same way that your brain would want to minimize wasting energy as much as possible with any movement. Running off with this study that was done on the parasternal intercostals, and they found that the upper parasternal intercostals had greater activation than the lower region during inhalation, which aligned with the leverages. And then we have this study that validated that observation and found that it was true for both conscious breathing and unconscious breathing. And again, this study saw regional activation differences of the parasternal intercostal muscles and found that the upper region had greater activation during inhalation and the lower region had greater activation during trunk rotation, which again aligned with leverages. And we have this study done on the external intercostals, and they found that the posterior region had greater activation than the anterior region to reduce lung pressure and take in air, which aligned with leverages. Then this study saw that during inhalation, the scalenes had greater activation than the sternocleidomastoid, which aligned with the leverages of those muscles. We have this study that looked at the psoas major and quadratus lumborum and found that different regions within those muscles behave differently, which aligned with the leverages of those regions. And we have this study done on a finger muscle, and what they looked at was the first dorsal interosseous muscle of the index finger. And since it originates on the thumb, altering your thumb positioning can affect the leverages of the muscle. We found that the muscle had worse activation when the thumb was elevated and greater activation when the thumb was by the side of the other fingers, which aligned with the leverages of that muscle. And we have this study done on the deltoids, muscle that you train in the gym, and they measured internal moment arm lengths of cadavers, and they compared it to the activation of various tasks in living people. We found a pretty close relationship between the regions that had greater activation, with them being the regions that had best leverage. So at the least, we have all of those studies done to directly test neuromechanical matching that confirm it. This is completely separate to the tons of indirect studies that confirm neuromechanical matching as well. So yeah, hope so far.